How's it going, AS Math? It's Mr. Knight, and we are here at the final topic for sequences. We've looked at arithmetic progressions, which deals with adding and subtracting, geometric, which deals with multiplying and dividing, and finally, exercise 3C, which is binomial expansion. Something we've kind of already seen a little bit. If we raise like x plus y to the second power, the third power, or even what we just did with bell work. But if I raise that to like the 17th power, we're going to be here a while if we try to distribute this thing. So I'm going to show you guys kind of an easier way of going about it and develop some kind of pattern. And it's also going to be handy because we can find really any coefficient that's going to be in our binomial. So if we look at this, here's our skills for today. First one is using Pascal's Triangle to find coefficients. We'll talk about Pascal in a little bit. Second thing is expand terms that have coefficients. So instead of x plus y, what if it was 2x plus 2y? Right? There's a way to do that. Third skill is using a calculator to solve for coefficients. Really handy dandy way of doing that. And then finally, skill 4 is finding any coefficients and becoming a master of math. Or at least of sequences. But a part of math, okay? So let's talk about Pascal's Triangle real quick. Pascal's Triangle looks like this, and I know it looks weird, and we're just going to talk about it for right now, and I have a handout for you guys in class that you can use that I'm going to pass out in a little bit, and then if you're a COLA student, I have it in your Schoology folder for Wednesday today, so definitely take a look at that. But let's talk about it right now. So Pascal's Triangle, let's ignore the purple right now. It starts with 1, it branches out to 1 and 1 again, and then it branches out to 1 and 1 again. But then it gets this middle term, which is 2. And then it branches out again, gets 1 and 1, and then it gets 3 and 3. And it keeps going. So what's going on? Well, these 1s are adding together to give me 2. This 1 and 2 are adding together to give me 3. This 1 and 2 are adding together to give me 3. And then in the same row, or bottom row right here, we have 3 and 3 that gives me 6. And the pattern just continues and spreads out infinitely. And I don't have a handout for an infinite Pascal's Triangle, but I do have one that goes through the 11th power. Because what this does, what this shows, is the base coefficients of any binomial expansion. So for example, if I raised this x plus y to the 3rd power, these are the coefficients I would expect to emerge out of that. Okay? And so on and so forth. It goes on, the powers increase. Okay? This r equals, this designates the position. So I'm using the bottom row as an example, but this would be for this n equals 5 row. This would be r equals 0, r equals 1, r equals 2, so on and so forth. We'll talk about the position a little bit more when we get to skill 3. Okay? So let's actually see Pascal's Triangle and see how we can use it. So what I'm going to do is I'm going to start expanding x plus y to the n. And I already kind of messed up, as you can see. This is not my first rodeo here, but it's okay. We're going to write below it. And so if I did x plus y to the 0 power, right, well, I'm going to end up with just 1. Anything to the 0 power is 1, so that's my coefficient. X plus y to the 1st power, well, that's just 1x plus 1y, which are the coefficients for n equals 1. What about n equals 2? Well, I expect to have the coefficients of 1, 2, and 1. 1, 2, and 1. Right? So if I have 1, 2, and 1 out of that guy, well, now how are my variables going to go? It's going to go 1x squared plus 2xy plus 1y squared. We'll talk about why that is in a little bit, but let's continue on. X plus y to the 3rd power. I expect my coefficients to be 1, 3, 3, and 1. 1, 3, 3, 1. Here's my variables. It goes x cubed plus x squared y plus xy squared plus y cubed. Maybe you're starting to notice the pattern in what's going on here. Okay? All right, last one. Let's get the coefficients for that. I expect it to be 1, 4, 6, 4, and 1. And now let's actually write in what the variables are going to be. Well, it's going to be x to the fourth plus x cubed y plus x squared y squared plus x y cubed plus y to the fourth. Okay, so how am I actually getting those? Well, I underlined my first term in blue and my second term in green, and I'm going to show you what's going on with that pattern. The first term is going to start at x to the nth power, right? So if I'm looking at this one, it starts at x to the fourth power, then it decreases by 1 every term, right? It keeps getting smaller and smaller until it's gone, right? The second term actually starts at the 0th power, right? It's gone. There's no y in this first term, but it gradually increases by +1 until it gets to the nth power. So that is the pattern. That is what is going on with our coefficients and the variables, okay? Kind of putting it all together. So for skill 1 now, I would like us to use Pascal's triangle to find coefficients and terms with coefficients, okay? So let's check this guy out. Let's see this example right here. So I'm going to start writing out my pattern. My pattern is n equals 4, right? That's the power I'm going to. My first term is x, my second term is 2. So I'm going to write my first term in blue, my second term in green, and I'm going to follow this pattern, right? Also notice, since I'm at n equals 4, I'm just using these coefficients, 1, 4, 6, 4, and 1. Okay? So I start off 1, 4, 6, 4, and 1. Then I start with my first term, x to the fourth, x third, x2, x, and then it's x0, which is 1. It's gone. And my second term, start at the 0th power. Then it increases every single time, right? So now I just need to simplify this a little bit more, right? Because if I just have 1x to the fourth to the 0, well, that's going to be gone. And I could just do x to the fourth. I know what 2 to the first power is. Times 4 is 8. So this is plus 8 x to the third power. This guy is 4 times 6, which is plus 24x squared. Plus 2 cubed is 8 times 4 is 32x. Plus just 2 to the fourth power, which just gives me 16. And that's it. That guy is expanded. Just using that pattern that we came up with. Not too bad, okay? Not too bad. But it gets a little bit harder. Of course it does. Of course it does. All right? Let's look at something like this. Okay? Let's try to expand 2a minus 3b to the fifth power. So now we're not adding anymore. We're subtracting. However, we can treat it like 2a plus negative 3b, right? That is our second term right there. I have to take that whole second term to each power, right? So if I do that and I set it up, again, I know my pattern is n equals 5, so my coefficients, if you're looking at your sheet, your Pascal triangle should be 1, 5, 10, 10, 5, and 1. Your first term is 2a. 2a to the fifth, 2a to the fourth, the third, the second, the first, and the 0 power. And then same thing with the second term here, starts at 0 and gradually increases. Now, here's where things might get a little trickier. If you need to recall this. You need to recall that if I have something like this, 2a raised to the fifth power, that 5, that exponent, will go to the 2 and the a. So it's 2 to the fifth times a to the fifth. Okay, so when we're simplifying this, that exponent goes to both. Same with this, second power and this negative 3b. The second power goes to the negative 3. It also goes to the b. So if I were to actually do that and get it going, 2a to the fifth, well, that's going to be 32a to the fifth, right? And then this is gone. And then for this one, again, this is going to be 2 to the fourth, which is 16. And then this is going to be times -3 times 5. You're going to get a -240 out of that. And then you're left with a to the 4th b, which makes sense because, right, our first term needs to gradually decrease, and our second term will gradually increase. And from here on out, again, it's just multiplying this 10, this 2 cubed, this -3 squared to get 720. This 10, this 2 squared, this -3 cubed, you get -540, and so on and so forth. It's a lot of calculator work at that point. Okay? So here is your reminder. Here's your reminder. Recall that 2x to the 3rd power is equal to 2 to the 3rd power times x to the 3rd power. Okay? That is huge, right? So if you can set it up like this, if you can do the pattern, you're going to be golden. Because after that, it's just calculation, which I could easily help you with if you have a hard time with. All right? Let's move on to skill 3. This is actually finding coefficients of the calculator. So we're no longer limited to Pascal's triangle, although we are going to use Pascal's triangle to help us figure out how to put it in our calculator. So any coefficient can be found with n over r in parentheses. That's how the book likes to write it. And it's where n represents the power, the exponent you're raising it to, and r is your position. Just like we showed with Pascal's triangle a little bit earlier, right? I had my r's and I had my n's. So in my TI-84 calculator, which is the standard calculator we use in AS Math, and it might be different on a different calculator, we have to use NCR, okay? I'll show you where NCR is in a little bit. But if I have something like this, 4 over 2, where my power is 4 and my position is 2, that is going to be 4 NCR2. So to put that in my calculator, I do 4, I come over to this math button, go over to probability, this perb, there's my NCR, and I hit 2, and I get 6. Now, let's compare that with Pascal's triangle. So I'm in the 4th power row, and I'm at position 2. Here's the 4th row. R equals 0, R equals 1, R equals 2. There it is, right? So that at least hopefully puts some faith in your calculator work, okay? So that's where it's useful. So the power lies in the Pascal's triangle still. So for example, what I'd like you to do, we're going to look at this, is I want us to find the coefficient of the term in the 8th position raised to the power of 11. 8th position raised to the power of 11. So when you set this up, this is going to be 11 over 8, which is 11 NCR 8, and you should get 165 in your calculator. What I'd like you to do in class is double check and verify, is 165 the 8th position to the power of 11? So that power of 11 row, the handout I give you, okay, the power of 11 should be down here, okay? And this is going to be the 8th position. So R equals 8, there it is, it's 165, just like we thought, okay? So now finally skill 4 is finding any coefficient. Now, this guy is really handy because now we do have some limitations with Pascal's triangle. Like I said, we don't go past the 11th power on Pascal's triangle. But in our original problem, what I asked you guys was, what if I want to do x plus y to the 17th power? What if I wanted to do that? Well, here's how we can do it, okay? Let's see this example. Let's find the coefficient of x to the 17th power in the expansion of x plus 2 to the 25th, okay? So we know kind of our pattern at this point. So what I would start off doing is I would start actually writing out your pattern. So for example, x plus 2 to the 25th, we know our first term is going to start at the 25th, and it's going to decrease and decrease, while the 2, the second term, is going to increase as we go. Now, we wanted x to the 17th power. So we're going to continue that pattern until we get x to the 17th. And because we want the coefficient, I can't just do, in my calculator, 25 NCR2. Because I have to multiply this 2 squared. That helps determine my coefficient, right? So, if I continue this pattern until I get to about here, my 2 is to the 8th power. Okay? And if you notice, the powers are always going to add up to n, which was 25. 17 plus 8 is 25. So now I'm going to, in my calculator, I'm going to do 25 NCR8. 25 NCR8. And then, after I get that number, which is a pretty big number, it's 1,081,575, I am now going to multiply that by 2 to the 8th power, and there is the coefficient for the x to the 17th power term. This would have taken forever if we tried to do it the long way, right? So kind of crazy stuff, okay? So this is kind of the first part video lesson to what I'm going to do for tomorrow. I'm going to make a mini video lesson that kind of touches on a couple other stuff as we continue our homework, okay? This is Mr. Knight signing out. Try to do some of those problems on your homework, and then we'll touch on it tomorrow.